Okay. Hello, everyone. Welcome to the first session of the Fast Delivery Track of TAC 2020. Just before I introduce the speaker and start the session, I just want to let everyone know if you have any questions during the session, there's a question option at the bottom. Please enter your questions. At the end of the session, there will be a poll push out, and that's also available at the bottom of the window. So our first speaker is Chris Riley. He's passionate about connecting the dots between modern technology and real business use cases. He spends his time connecting with practitioners and vendors to understand how technology is used to increase application quality and release velocity. He's the host of Developers Eating the World podcast and has an eclectic set of hobbies. Welcome, Chris, and over to you. Chris, I think you're on mute.
There we go. If that didn't happen, then it wouldn't be a virtual event. So I'm going to shuffle my screen here very quickly and make sure that I have everything where I want to have it. So I'll just need you to confirm that you see my screen here in 2 seconds. All right. Do you see my screen, the picture of me?
Yes.
Cool. In the timeline. Great. Good. We're good to go. So thank you, everybody, for joining me here today. And it's always a pleasure to be invited to do events like these. And I appreciate everybody who arranged this. I know how much work this is. It's a tremendous amount of effort. And I do not take that effort lightly because that's something that I am not good at. So to begin, I just wanted to do a brief introduction of myself because I think it's important to understand who the person is up here chatting with you and why we think that we are should be up here. So my name is Chris Riley. If you scan that QR code, you'll be able to get access to my social information. I call myself a bad coder turned advocate. And the reason I say that is I started my career out in the IT consulting, IT services space. And I quickly kind of went down the path of wanting to be a software developer. So I moved from Colorado to the Bay Area, chased my Silicon Valley dream, wasn't exactly what I expected it to be. And what I learned at the time is that I was good at application architecture, but I wasn't so great at the business of building applications. And what I mean by when I say that is working within teams, release automation, all the things that are around application development that are beyond just building code. And I think that's interesting because I find that a lot in people who are just learning to become developers today. Fortunately, during that time, this new role, advocacy and evangelism, came to be. And I was able to basically be able to talk about software development without actually being responsible for building the applications. So I get to have a lot of fun engaging with practitioners and developers out in the field, and then bringing that knowledge back to Splunk so that we can better serve the development persona, and particularly in the days of DevOps and SRE. So anybody who wants to connect with me, please do. I love to have the conversation, and the best way for me to learn is by having the conversation. Constantly have to be engaged with practitioners and find out about how things are really done. And today what we're going to talk about is observability and the SRE. So these are two brand new terminologies that have come out. And sometimes the new terminology can be really frustrating because you just think that you get your bearings on new terms like DevOps and all the things around CI, CD, continuous integration, continuous delivery, and then a new term is thrown at you. And I kind of share that frustration. The way I embrace terminology is when I can align it to specific use cases. And I've jumped on the observability and the SRE bandwagon. I think, in particular, SRE, we're not. It's becoming more of a mature practice, whereas observability is kind of a brand new concept that is the next evolution of monitoring that we're going to talk about. But before we go there, I kind of want to talk about the problem space, because to really understand why we talk about observability and SRE and why they're even things that we should think about, we need to understand really what's going on in the market that has caused this disruption and change. Once we do that, we'll talk a little bit about what is observability and what does it mean to bring observability into your organization. What is SRE? And ultimately, how do these two concepts roll up to change the way on-call works in enterprises? And then we can have a conversation. And I think there should be plenty of time for questions. I will try to go back and look at the questions from time to time here, but there should be plenty of time for us to have a conversation as well. So a lot of companies are guilty of looking at their favorite large tech company and trying to simply emulate what they do. I'm going to pick on Google. You could pretty much put any large tech company here, Uber, Netflix, Twitter, Facebook, etc., and the outcome is pretty much the same. And that outcome is basically that these companies have resources that are just tremendous and would be difficult for anybody, most people, to recreate. They also give back a lot to the community. But sometimes when they give back, they give back technologies that are highly disruptive. The biggest challenge with trying to emulate and learn from these companies is not that what they're providing isn't useful. It's that most of us do not have the transaction volume or the capacity to justify doing everything that they're doing. But we can learn from the practices that they adopt and introduce to the world and build on top of that. So Google in particular, what did they give us? First is Kubernetes. We all know what Kubernetes is. Kubernetes kind of fixed the problem that we saw with containers, with Docker containers, which were just picking up very heavily during this time. And it's the orchestrator of containers. So the challenges we had were containers were so easy to spin up that we didn't have management processes and easy ways to make sure that they were continually running, that if we had hundreds of these things that we could manage them. Why Kubernetes won the container orchestration race, it's hard to say. Arguably, it's not the easiest to use. As a matter of fact, Docker Swarm probably is easier to use than Kubernetes. But we can say that Kubernetes is one, and it's becoming somewhat ubiquitous in the container orchestration days, or in these times. The other thing, the bar graph there, those are golden signals. So Google came out and said, hey, these are the KPIs you should be measuring all of your applications by, because they're the ones that we use. They didn't actually say it that way, but because they had this thing called golden signals and how they were monitoring their applications, a lot of people wanted to do exactly the same thing, assuming that that was exactly the right way to do it. The other thing they gave us is SRE, Site Reliability Engineer, which I would argue should be called Service Reliability Engineer, because that's what we're all building these days, our services, and the idea of a site, both physical and virtual website, are not as relevant. But the SRE role changed the way we think about supporting and monitoring our applications in production and how we deal with all the stuff that we learn from production level incidents. And then you have this idea of canary releases. So canary releases are the ability to release new functionality rapidly from the development box to production to a subset of your audience. The thing that's really useful that it came from canary releases is this ability to force organizations to have rapid rollbacks when they release new components of their application. But most applications don't have enough transaction volume at any given time to justify and really do A/B testing. So we still learn from all of these concepts. What the big tech companies didn't realize that they were doing was creating this massive tsunami wave of change throughout organizations that not only impacted the technical aspects of the application, they also impacted how we organize our teams, how our culture operates, how we deploy these applications from a processes standpoint and a strategy perspective. And so all of this change really gives rise to a need to have a different type of conversation. Our traditional conversations around monitoring and supporting monolithic and traditional infrastructure wasn't going to be sufficient in order to talk about the new challenges we have with modern infrastructure, modern application processes, and modern application architectures. And then we'll start with observability. So that's really where the catalyst of all this comes. I'm going to quickly take a look. No questions, but we have a lot of people attending, which is great. So what is observability? It's really hard to talk about observability and not use the word monitoring, which raises the first question. Is observability monitoring? Well, yes and no. It's definitely an extension and growth of monitoring. But the reason we use a new term is because we're in a new phase of building and deploying applications. So if you look at kind of where enterprises are in their journey to building and deploying applications, on the left side, you have traditional monolithic infrastructure, where there tends to be a wall between development operations, and usually that wall is many layers deep. This is infrastructure that you deploy, you set it and forget it. So we're largely past the days of racking and stacking, but this is going to be maybe a private cloud, maybe your own data center if it's highly secure information. But you stand up the servers, you put your virtual machines on the servers, you configure them, and they run until something bad happens. A lot of organizations are staying there because they can, and they don't really have a need to move. And most of the workloads on these types of infrastructure are internal. So they're going to be line of business applications. They're going to be applications supporting the internal organization. But now companies start to have to think about what's next. How do we meet the demands of our users for our public applications and transition this big investment we've made on traditional infrastructure and move it to public cloud? So that's where you get into the lift and shift and refactor stages. So lift and shift, someone could argue that you could just skip this step, but lift and shift typically is where you will start to containerize your traditional infrastructure and your workloads, and you'll move them to the public cloud. You haven't actually changed how they operate. So you still have this turn it on, get the service running, and leave it mentality, but you are moving it to the public cloud, which gives you access to many more services that the public cloud has to offer to start to move in the direction of cloud-native applications. And that's where we get to refactor. So refactor is where you have it in your public cloud and you start to pick apart your monolithic applications into microservices or services or medium services, whatever you choose, because micro is not honestly a fair term when you talk about services, because it's not just a matter of the size of the application. But you are starting to look at more modern ways of building and deploying your applications. This is where things change radically. A lot of organizations, you may have heard of the strangler pattern. The strangler pattern is the process of going from lift and shift to refactor, and where you take new services that you're onboarding and you build them as microservices, or you slowly pick apart the existing services and move them to microservices. Then you have all the way to the right of the spectrum, which is cloud native applications. These are applications that were born in the cloud. They're a combination of microservices, serverless, other PaaS services that you consume from your public cloud. And again, cloud native doesn't necessarily do it justice, because it's not just the infrastructure here. It is the relationship between the infrastructure and how you support these applications. So I think a lot of organizations are onboarding new applications as cloud native, but most enterprises are going to have some combination of all of these. And when we look at the traditional enterprise, most enterprises are in the lift and shift and refactor stage, because they're starting to prepare for what it means to be cloud native. Now, what's interesting about this is as they start to refactor, one of the things that they find out is that releasing software at a greater cadence, a higher release velocity, may not be the hardest part. The hardest part may actually be managing all of this stuff, because we have now increased the complexity and the nature of our infrastructure. So our bottleneck is our management plane, not necessarily the code itself and the release automation, because that's fairly mature. And why is that? So why do we see a challenge as it relates to not just deploying these applications, but also managing them? Well, in the monolithic application architecture, when you deployed your code, you deployed it onto a server. So this server configurations may have been updated from time to time, but the biggest change that happened on this server was the code that you were shipping, the artifacts that you shipped. It was slow moving, changes were infrequent, and the amount of interaction with the infrastructure was just not at the same parity as you see with public applications. As we transition to microservices, not only is it changing how we deploy code, our code is not only code. We're actually deploying the infrastructure as well. And this is a key point, because when you're actually shipping containers that have configuration, infrastructure, all the elements of the infrastructure, including the operating system and your code, then they are fully tied together. And now you have a highly distributed environment with many hosts. It could be in many regions. It could be on multiple clouds. Multi-cloud is a big practice that many organizations are adopting. You're going to have higher transaction volume, and changes are going to be frequent. But the way changes work in this case is that these services generally are deleted and replaced. You're not updating them like you would in monolithic infrastructure. And as a result, they're very short-lived. So they're stateless and ephemeral. Being short-lived makes it harder to monitor, because the relationship between the services is changing constantly. So we've increased our release velocity with microservices and using containers. But we've created a whole new set of challenges when it comes to supporting them in production. And to illustrate that, here's just one example. So I think a typical organization could have around an average of 50 services. If you look at companies like Uber, they have tens of thousands of microservices. Not only are each of these services independent, very often they have their own stack. One could be also a third-party service. One could be serverless. So not only do you have many of these things and all of their relationships to each other, which are considered contracts, you have different types. One is written in Python. One is written in Node. One is a serverless function. One is a third-party API. So when you wire these up, and you expect them to give you alerts to tell you when something is wrong, because that's what we expect from our systems. Where the alert comes from may not be the source. So in this diagram, what you see is that we have a front-end application that is delivered an alert to us. Maybe that is the source of the alert or the incident that your on-call team gets. But the actual problem is in the product catalog service. In a traditional approach, when something breaks, you use metrics, and you usually know exactly where to go to solve the problem, because it's either related to a deployment or something's going on with the infrastructure, disk full, memory, CPU, etc. In this case, we don't know where to go. The operator can't just intuit where the problem is, because it's the front end who said that something's wrong. But when we look at the front end, everything seems fine. Really where the issue is in our catalog service, which could be a MySQL database or whatever. So you need a new approach that can get us to finding out exactly where the problem is, all of the other services impacted, and get to resolution faster, because you can't just traverse that naturally when you have tens, hundreds of microservices running. That is what observability is. Observability is a term used to encapsulate that problem that we're talking about of highly distributed systems. The thing with observability, like DevOps, like SRE, is it always has, all of these terms have a component of strategy, of a function, and of tooling. And observability is no different. So observability is rolled into your development and deployment strategy. And I'll talk more about that in a second. But for example, the way we do observability, our SRE team is responsible for building the strategies for being observable, because it's something that you have to consider when you build your applications. Are you instrumenting in your code to collect data? Are you instrumenting on the infrastructure level with agents and maybe the sidecar pattern, which is a pattern where you have a service and you basically have a agent monitoring or connected directly to that service? So there's a strategy elements. It also is an approach. So it will drive how you build your dashboards to support your applications. It will drive how you manage your on-call, and if you embrace something like SRE. And it is also tools. Tools being new set of tooling that can facilitate this approach, namely being able to collect traces and spans, which is a new KPI from your application. When you should consider to use observability is when you're deploying infrastructure, configuration, and code all together. So you're shipping these containers that are ephemeral, they're stateless, they're immutable. When you deploy it and you want to tear something down, you delete the old instance of all the infrastructure and you just replace it. Also, when metrics are not good enough. So we are all familiar with like traditional metrics around CPU and all of your compute. But that's not sufficient for modern applications. There's much more things going on, all the way down from the user down to infrastructure that you need to monitor. As your infrastructure becomes more distributed, and when we say distributed, it's not just distributed in terms of number, it's distributed in terms of variety as well. So you have different stacks for different services. And as I said already, that the components are immutable, stateless, ephemeral. They are short-lived. They may only be there for 5 minutes. They could be there for hours, but they are easy to tear up and tear down. This is when you start to think about observability. Now, what's interesting is observability really goes hand in hand with the SRE role. And I can't really think about environments that I know of that don't embrace both. Usually SRE has come first. SRE is a less new term than observability. But the SRE role or the SRE function is hand in hand with observability, and perhaps is what kind of brings that practice into an organization. But again, is this something that you just adopt because Google did it? You know, why would you even consider this new SRE role? Well, first of all, some organizations will just rename their NOC to SRE and without changing anything. And so sometimes the term SRE is just used as a new name for what's already been done for operations. However, the goal is that by adopting SRE, you are changing the way you operate your organization. So it's not to be Google, it's not to be a unicorn. By the way, both of these graphics, the unicorn graphic is from the Unicorn Project, which is a book by one of the authors is Gene Kim up there on the right, and that is a photo from last year's DevOps Enterprise Summit. So it's not to be the unicorn. That's not what we're trying to do. Really what we're trying to do is keep pace with the demands of the modern user. Because at the end of the day, that's why we do all of this. And the modern user is extremely demanding. I'll give you an example of this that is very timely and recent. As soon as the shutdown happened in the US, the first thing that we had to consider, because my girls were still in school, was how we were going to embrace virtual learning. And now it's another problem that we're trying to figure out. So what did we do? We went and looked for being good tech family, I suppose. We went and found a nice, mobile app that was well known for delivering education material to kids in a very easy to consume way. Arguably, this particular application has been around the longest. So they were one of the early mobile applications for delivering education via iPad and iOS. The content was great. It may be the best. But the interface, the experience of the application was not the best. And despite the high quality content, we quickly unsubscribed from this application because it wasn't meeting our expectations from a user perspective. It wouldn't launch all the time, and the interface wasn't as expected. And when you clicked on something, it didn't do what you expected. And we went and signed up for something else. So they lost a customer based on experience. And that is why we do what we do. If you have a public user-facing application, customers, modern users, are extremely demanding. And part of the SRE role is to not serve traditional operations, basically served the infrastructure. You're not serving the infrastructure. You're serving the end user, and everything works back from the end user, including deciding what you measure. And in modern applications, latency is the new downtime. So if I click on a button and I have to wait, I think it's broken. That is how users behave today. So it is not good enough to think about services being down and infrastructure being down. You have to think about the full end-to-end experience. By the way, in that last slide, that's Jonathan. He leads a part of our SRE team, and I've learned a ton from him about SRE, and he's corrected me on many times about really what SRE means. And what it means, yes, we are modernizing the NOC. So we are changing the way network operations work. In today's world, it's distributed. So you no longer have that room that you go to and sit in, and you have your video games and your sports on one screen, and every other screen is monitoring infrastructure. But it's also, we do this because we need to keep pace with the new release velocity. People releasing new versions of services, each service with their own independent lifecycle on a daily, monthly, weekly basis. Customers demand more. I mean, We know that end users intuitively now understand the difference between a good application and a bad application. And development teams can't be removed from operations. They need to be together. They need to work together. Development teams need an operational partner to be able to pull this off. So before we had the SRE model, we had the NOC. The NOC was largely driven, like I said, physical room, staff 24/7. You had 3 or 4 people in the NOC watching everything going on. When something broke, they used a spreadsheet to decide who to call. They were usually focused on the core infrastructure, not the application layer. They had little dev experience or connection to the development team. And when something broke, they leveraged one of 2 strategies typically. The first strategy is spray and pray. That's where something breaks, you blast the entire organization, and you hope that somebody picks it up and acknowledges it and goes to address the issue. And a lot of times this was done via email, very slow, or an ITSM system. Or they use lazy mobilization. Lazy mobilization is you go and you find that one person who always fixes everything, and you just call them because they always fix everything. Usually it's very effective, but it's not effective because that person's going to get burnout and eventually not going to deal with it anymore. Whereas in the SRE model, you have to have automation. You have to rely heavily on automation. The application layer itself is also part of what you're supporting. And in the SRE model, the SREs sometimes aren't even on call. Usually they are, but they're not the only ones on call. Most of the time in the SRE model, anyone can be on call, and usually developers are on call for the code that they deploy. But the SREs help them build a strategy to make sure that they're the most effective and efficient at doing that as they possibly can be. So the responsibilities of the SRE role or function are different than what you see in the NOC. There's much more strategy. They help define what sort of metrics are used. How do you deploy new services? So within our SignalFX team, anytime a new service is deployed, the SRE team works with the developers to decide what metrics are used to monitor that application. And it's not just the golden signals. Usually what happens is at a service layer, you have a set of metrics that you watch, and they could be many. And then at a global layer for the entire application, you have standard metrics that everybody in the team understands. Whereas a service layer, maybe only the service owners understand it. And there's lots of ways to slice and dice this. Red is one of the most common. And then there's others. There's use, there's et cetera. What you pick depends on what is most representative of your users. So they are also stewards. They end up providing stewardship of DevOps, of automation, of these modern support practices to the rest of the organization. They are an operations function. There is no denying that, but it has changed how they approach operations. And they usually own on-call. So they're usually the ones responsible for setting up on-call strategies and helping make sure that those people who are on call in rotations and schedules are as effective as they can be and trying to avoid burnout, because that really matters a lot. So let's talk about what that means. What is on call for modern applications? Well, first of all, we need to kind of clarify what an incident is. Your alert, and I like to use the analogy of your car breaking down. Your alert is the engine light that comes on in your car. You don't know much about what's happening yet. You know something's wrong. You pull over to the side of the road and you get help. That is incident response. Incident response is the mobilization of the right people at the right time. So they're going to be notified by phone in the case of, you're probably going to call the person to come help you for roadside assistance, but you're going to notify the right person for the job in the best efficient way based on a call down schedule, rotations, etc. Once they get there, they're going to help you triage the situation. They may or may not have enough information. If they don't, they're going to go and get that information. That may be accessing dashboards. It may be going and getting the right subject matter expert. In this case, in roadside assistance, they might take your car to the shop. Once they take your car to the shop, they're going to plug your car in and find out exactly what's going on, getting incident codes and all the codes that come from cars. By the way, an older 1998 Toyota is going to have a totally different behavior than a brand new Tesla in the telemetry data that a Tesla can produce, which is a lot more granular and much more like a modern application, whereas the 1998 Toyota is more like a monolithic traditional application. So they're going to work to resolve the issue. Their job's not done. Once the issue is resolved, they're going to keep a record of everything that happened. That is what incident management is. So incident management is your Carfax. In the US, we have something called Carfax, which is a record of everything that has happened with the vehicle. That is going to be your system of record, and it's going to be tools like ServiceNow, etc. So incident response is a very short window, but it's all about firefight, getting the right people and getting to resolution as quickly as possible. Now, how that relates to your tooling is your observability tool is the alert and the context that feeds into an incident. Alerts aren't incidents. Incidents often are an aggregation of alerts from many services. Incident response, as I said, is the mobilization and the action of the right people to solve the problem. And then incident management is how you keep track of the audit trail, all of the activity that's happened associated with an incident. And as I said, there is a lot going on there. And that is why making sure that your processes and strategies around incident response are effective. So you get an alert, a whole bunch happens before it even gets to those people who are on call. And then all of that data is fed into an incident response platform, maybe a collaboration tool like Slack and Teams, and also potentially other automation. Maybe you trigger a run book to run on your infrastructure to do specific things for common issues that you know. And this is what a typical incident lifecycle looks like. So this is a micro study done with actual customers who have gone from a traditional NOC type infrastructure to the SRE model. So what you see in the traditional model, and this can range widely based on applications, is an average of 25 to 45 minutes just to find the right person. Once you find the right person, you see an average of 6 hours of effort, 5 reroutes, meaning you send it to somebody else, and a total of 8 people resolved. Your job's not done until the service is restored. And sometimes that takes a long time, depending on what actually went down. Good thing about modern architecture is it can be much faster. When organizations embrace the SRE model, we see this curve flattened. It's less than 2 minutes to get somebody to acknowledge, get the right person to address the issue, less than 2 hours in remediation, and fewer than 3 people involved. So the effort, the complexity is reduced with a good, strong SRE model driven by observability and a good incident response tooling and strategy. What does good mean? Well, the key components of a good incident response platform is that the on-call experience is customizable. So those people who are on call can be alerted in the ways that they want to be alerted, when they want to be alerted. So for example, if it's during working hours, maybe email is sufficient. But if it's after hours or at night, you need a phone call, especially if you sleep like I do. You also need the ability to get the right people into the firefight, the right subject matter experts, because modern application architectures have a wide range of stacks and configurations. You need to have the ability to build a war room. This is get everybody in the same room when these issues cascade, because they can, sometimes they do, and you want to stop that as quickly as possible. And it needs to have integrations with communication tool, input sources from the observability platform, ITSM, which is bidirectional with your ticketing system, as well as communication and collaboration with like Slack and Teams. All of these things come together to represent the modern environment where the complexity of infrastructure and applications has changed dramatically, that tsunami wave of change. And to address that new complexity, because like I said, organizations have found it's easy to go fast, but it's hard to make sure that that velocity is sustainable and extensible over a long period of time. And that is your management plane, that is observability, that is SRE. And I'm going to end it there with a page of resources. These are just some fun blog posts that recently went up. We have a blog post on how we do SRE, which I think it's always interesting to learn from, you know, some of the big tech companies out there, how they approach SRE. There's an article on DevOps.com around the modernization of the NOC, which is very similar to the content I've provided here. A very good webinar with Jonathan that you saw that quote from on how SRE is in the real world. I have a podcast where I interview a lot of SREs, as well as people across the board, developers, operations, called Developers Eating the World. And another thing that I haven't talked too much about yet is the Open Telemetry project, because a big part of modern applications and supporting them is getting data out of them, getting delayed telemetry data out. The Open Telemetry project is an open source project backed by the CNCF, and it's all about open instrumentation to get data out of your applications. I'm really tripping over myself in terms of words right now. I'm going to actually leave it on this slide in case anybody wants to grab it, and then I'm going to navigate back to Chrome. Looks like we have a few questions. How much more time do we have left? 3 minutes? Something of that sort?
Oh, we've got another 5 minutes.
5 minutes? Okay, great.
Oh, no, sorry. Yeah.
Let's take a look at the questions here. Okay, yeah, so I'm going to start with the first question. What are some of the pitfalls in adopting observability? It's a really good question. I don't think that there's a clear answer to that. I think that every organization has a unique set of challenges, which tends to scale by size of the organization. The larger the organization, the harder. I'd say that the biggest pitfall, especially for large organizations, is not focusing on how you collaborate across teams. So companies like Delta, they have a whole team responsible for running dojos across the organization to educate developers, educate everybody on what SRE, what observability actually means to them, both technically and from a communication perspective. Organizations that don't do that early on and only go out and expect the observability tooling to bring observability into their organization are the ones that tend to fail. And this has always been the case. It's another good example of this is the world of SharePoint, and that's top of mind for me because I used to be a SharePoint developer. Organizations that expected SharePoint to help them be better at collaboration and content without thinking about the strategy of doing it and how they work together tend to fail. Let's see, level of maturity in DevOps. Okay, so DevOps is not an end. DevOps is something that You're always doing. It's a journey. There's never a point where you go, we are DevOps. No, DevOps is something from a principles perspective, because there's a principles in the practice. From a principles perspective, you have to it's a mindset. Now, from the practice, there is a maturity. You can't really embrace SRE until you have the automation around continuous integration and continuous delivery. So until you have more or less fully automated your builds and your testing, because quality matters a lot in this whole spectrum. You build bad code, you're going to deploy bad code. Then you can't get there. So you're going to have a release automation tool like Jenkins or Spinnaker, or all the others that are out there. I don't mean to just isolate it to those. And you're going to be able to go from deployment to your main branch in your repo, through a suite of testing, up to release. You don't have to go through to releasing continuous deployment. But you need to have that kind of automation ready to go to really support SRE and observability. How is SRE a part of change management? That's a really good question. So actually in that webinar I sent you, this question came up as well. Operational drift and change is a problem that has been largely unsolved and neglected, and I think is probably a new category of tooling that's going to be coming in the future. SREs help identify gaps from what things were said to be and how they actually are, because operational drift is very different. In our organization, the SRE will drive a regular activity with the development teams by prodding them, because they don't manage them, by prodding them to update their documentation as it relates to their service, make sure that their on-call schedule is appropriate and needs to be updated, and they will do this on a quarterly basis. So SREs are stewards, again, of change management, change control. They don't actually implement it. And I would say that operational drift is something that everybody needs to be aware of. Developers need to understand that what they do in their local dev environment can eke its way into production, and the potential compounded risks of that. These are all fantastic questions, and I really enjoy every event I've done with this crew, getting fantastic questions. Keep them coming. If I did not answer your question, please reach out to me, and I can give you a more direct answer after the fact. And I think that, I don't know if my slides are available or not, but we'll try to get the slides to you where you can get my contact information there. So thanks, everybody. I really enjoyed the time. And yeah, I hope to join again in the future.
Hey, Chris, thank you so much for joining us. I know it's really tough, especially doing everything online.
My coffee started to kick in. That's why I was stumbling the whole time.
Yeah, thank you so much. And I'm sure that there's a lot of inputs that we were regaled with understanding SRE versus NOC, and it was a wonderful session.
Great.
Just a reminder to everyone, please look at the poll section below, and our session has come to an end. So thank you, Chris, and I would request everyone to click on the schedule option, the menu on top, and to attend the next session. Thank you once again, Chris, and thank you, everyone.